Thank you, Zeke. Good rat, Zeke. Okay, this is a short video to explain how to do part C of a question on a Welsh A-level past paper. So this is the WJEC exam board. It's AS Unit 2 from 2022, question 3. It's a Poisson distribution question. And parts A and B walk you through the first part of the story. It's to do with counting earthworms in a soil sample, and they give you a fixed dimension for the sample because Poisson has to do with how many occurrences you get in a fixed interval. So a given volume of soil is a fixed interval of space. Okay, and so parts A and B give you the average number of occurrences. They give you lambda, and you have to do things with the distribution. And then question C asks the question kind of the other way around. They say, okay, we're now in the autumn. So the number of earthworms on average has a different mean than it did in the first half of the question. But we're just told that the probability when we take a sample of soil, the probability that we find, excuse me, gods, I can't talk today. The probability that we find fewer than 13 worms is about 36%. And they want you to work backwards to figure out what the average rate of occurrences should have been. And the thing is that for different values of lambda, the probability of getting fewer than 13 occurrences in a particular sample is going to be different depending what the average rate of occurrences is. So this question, the notation goes like this. They're asking for the probability. So X counts the number of worms in a soil sample. Okay, and so saying that the probability that you get fewer than 13 worms. And because Poisson is discrete, that is, X is whole numbers, I guess you could have half a worm. That's sad. I don't want to think about partial worms. So whole earthworms only, please. The probability of being less than 13 is the same thing as the probability of being less than or equal to 12. They want that to come out at about 36%. And the way I like best for dealing with questions like this is to use stats tables. So here are the WJEC stats tables for the Poisson distribution. It's only one page for what they give you. You can buy stats books that give lavish detail, loads of choices for lambda, and then all the matching probabilities. But this is good enough for A-level. They only give us some, and that's all we need to answer the questions. Okay, so stats tables are cumulative affairs, and that means it doesn't give you the probability that your random variable equals a particular value. It gives you the probability that your random variable is less than or equal to a particular value. So for example, suppose the average rate of the average number of earthworms in your soil sample, maybe you get one worm per sample on average. Okay, so the probability of finding one or fewer worms is about 73%, 7358. Okay, the probability of finding two or fewer worms is 0.9197. The probability of finding three or fewer worms is 98.1%. Four or fewer is 99.6%, and so on. By the time you ask for 6 or fewer worms, if on average there's one worm per sample, well, you're practically guaranteed, by the time you get to 7, the decimal places that are different are so far out that everything just rounds up to 1 at this point. So this is cumulative probability. I hope that makes sense. If that doesn't make sense, let me know and I'll try to say more words about it. So I am looking for 12. So when lambda is little, so the average rate of occurrence of whatever it is that you're looking for is low, then the probability of getting 9 or fewer things found in your sample is practically guaranteed. So they don't bother to print the numbers any higher. And if we line wrap, this table uses m instead of lambda. I don't know why. You got me. Whatever, one of those weird idiosyncrasies we have to live with. Okay, so by m, they mean lambda. Okay, so these are choices for lambda. And I'm looking for where they offer me 12 or fewer. And they repeat it over here just to help you'll look at the numbers without going too cross-eyed. And this is saying that, when lambda is 5, if you have 5 worms occurring on average, then the of finding 12 or fewer worms is 99.80%. That's way too high. Okay, so we need bigger lambda. So let's go further down our table. So here's some more choices for lambda. Here's my row 12. I'm looking for where this drops to about 36%. You can see that it's dropping. And right here at lambda equals 14, we're almost at 36%. When lambda is 13, we've got 0.4631 as the probability of finding 12 or fewer worms. But if lambda is 14, then the probability is 0.3585 for finding 12 or fewer worms. And if we jump up to 15, then our probability is a lot less than 36%. So they did ask for the nearest whole worm on average, the nearest whole number on average. So we're going to take 14 because that's practically 36. That'll round up to 36%. And there's our answer. Okay, so just to write those values down, the probability that, and you might show this on your exam script just to let them know that you know how to read stats tables, that the probability that x is less than or equal to 12 when lambda is 13, that shook out to be 0.4631, but when lambda was 14, the probability that you get 12 or fewer was 0.3585. And that's what we're going for. You can do this on the calculator, but I think it's a lot faffier and a lot more difficult. What you would do is because they say lambda to the nearest whole number, okay, that gives you an idea how to start guessing. So you might just pick like 9 and run the probabilities, and then pick 10 and run the probabilities, and pick 11 and run the probabilities. I'll show you what I mean, but you go until you hit something around 36%. And basically what you're doing is you're generating a row like this by hand, one little calculator screen at a time. But the nice thing about the stats tables is that you can just look across the whole. You can think of this as a calculator printout if you wanted to. You can look across the whole printout and find your number straight away, and you don't have to tap blindly on the calculator. So stats tables are still relevant and valuable, but to do it on the calculator, I would do it something like this. I don't have the thick fancy Casio. I have the little fancy Casio. So if you are on a different model, your steps might be a little bit different. Okay, but the general idea is this. We want statistical distributions, that's option 7. Okay, and I want Poisson cumulative, so that's option 3. Okay, I want variable. And the x I'm interested in, well, cumulative, I want less than or equal to 12. Okay, and I'm going to take some guesses at lambda. So I might guess lambda equals 9. And if I press equal, this is the probability of getting 12 or fewer worms if lambda happens to be 9. And that's way too high. And you're like, okay, that's no good. 9 was no good for lambda. All right, well, let's try 10. Nope, that's still way too high. All right, let's try 11. And you just go through your numbers one by one until you hit around 36%. And you'll realize that by the time you you guess for 14. There you are. And you might want to test 13, you might want to test 15 just to make sure. I guess if we had just checked with 15, again, from the tables, we would have found it. Lambda is 15, then your probability of getting 12 or fewer hits is 0.2676. Yeah, that's way too low. That's nowhere near 36. 14 is what we want. So that's how you would do it on the calculator, is just, trial and error one by one. But why do that when you've got the printout right here that'll show you? So there you go. There's your there's your earthworms. I think trying to understand statistical distributions and what it is that they're saying is quite a sophisticated thing. So if you have any questions or want me to elaborate further on any aspect of this, please let me know. Okay, thank you for watching.